All right, guys, let's knock out this review for test 9. Number 1, it says convert that 72 degrees 55 minutes to decimals. So 2 ways you can do that. You can go to second apps and punch in your degrees in minutes, or you could also do 72 plus and then go like 55 or 60 because there's 60 minutes in a degree. Punch that straight in your calculator, you get 72.92 to 2 decimal places. Number 2, straight up calc. Make sure you're in degree mode though. I think your whole test you can be in degree mode. Sine 54 degrees, just punch that straight in, you get 0.8090. And then to punch in cosecant, there's not a cosecant button, so you got, remember cosecant's reciprocal of sine. So you actually got to flip it and do the reciprocal of sine like that. So I'm punching in 1 divided by sine 49.5. I'm getting 1.3151. If you're looking for theta, when you're looking for theta, you don't know the angle. You're looking for the angle, that's when you hit the inverse sine or inverse cosine. So this time I'm going to hit second sine, which is inverse sine. Just punch decimal 0.226. Oops, 2226. And hit enter, and I'm getting 12.9 degrees on that one for theta. And then number 4, what is the exact angle for sine? Theta is 1/2, and it says exact. Those are the ones you're supposed to know. It's either 45 or 60 or 30. Those are the ones that we know right now. And where's sine 1/2? At 30 degrees. If you need to, if you forgot those, if you can't remember them, I hope you don't, but just in case, you can always draw a right triangle, make it 30, 60, 90. The 1's opposite the 30. The square root of 3 is over here, the 2's hypotenuse, and you can just go like, oh, sine is opposite over hypotenuse, and you can find it that way also. But you will have to draw the triangle, those won't be in your test. Number 5, pretty quick and easy one I feel like right there, just find the inverse. So remember inverse is when your x's and y's switch, so I'm gonna put the negative 8.5, can't believe I'm actually doing this, 7, -2, 9, 4, and then -5.2, and there's your inverse. Then the next two, you got toughest 1-to-1, and I'm gonna be honest with you, they're gonna be 1-to-1. And then find the formula for the inverse. So what I'm gonna do is switch the x and y's. Remember, first step, take the x and y, switch them, then get the y by itself. So switch the x and y's, now isolate the y. Move the 2 over first, then divide by 5, and you get x plus 2 over 5. And I'm gonna take the y, remember, we're gonna write inverse of f to show the proper notation there. Number 7, gonna take a little more room. Same steps though, take the x and y's and switch them, put the x over there, put the y over here. First step, I'm going to cross multiply, so I'm going to go x times down there, so it's x times y and 5 times x. Take the 1 and do the same thing, 1 times y minus 2 is just y minus 2. Next step, which is an important step, you got to get the y's together, so I'm actually going to switch sides with the y and the 5x. If I pull the y over, it becomes minus y. If I pull the 5x over, it becomes minus 5x. Factor out the y, that's the next important step, equals this. Now, that's a 2, I don't know why I just wrote a 1. Because this side right here says y times x minus 1, the opposite times is divide. So I'm going to divide both sides by the x minus 1, like that. Because that gives me my y by itself, I'm going to go ahead and replace the y with the inverse of f of x. And that's it. Number 8, pretty cool problem because you know the answer before you begin. It says use composition to show that they are inverses. Remember, when you do that, you got to do f of the inverse of f, and also go backwards, do inverse of f of f. And remember, you're going to get x both times if they're inverses, and it's telling you in the problem to show that they are inverses. They are inverses, so you're going to get x. Just show your work. So when it says do f of inverse of f, I'm going to plug the inverse into the function. So I'm taking the second one, I'm plugging it in. So I'm going to take that x cubed minus 4 and put it where the x was in the first equation, except I put plus 4 for some reason. There we go. So I'm going to put minus 4 and then a plus 4. What happens is the 4's cancel, which leaves me just x cubed in there, and the cube root of x cubed is just x, which is what I should have gotten. The second one, I'm going to go backwards. I'm going to plug in function f, the first one, into the second one. So I'm going to take that x plus 4, the cube root of x plus 4, cube it, and subtract 4. If you cube a cube root, the root goes away, so you get x plus 4 minus 4. The 4's cancel, you get x. Imagine that. Number 9, graph it, determine if it passes. Here's what I know. Well, you can use your calculator if you want, so you can go to y equals and punch it in. But here's what I know. I know it's been shifted up to. It's x cubed, which is half up, half down, except there's a negative in the front, which means it's half down, half up. It's going to look like that, which means it does pass. If I drew a horizontal line, I can just hit it one time. That's a yes. Number 10, You got to draw your own right triangle. So I'm drawing my right triangle here. It gives me sine up here. Sine is, I'm gonna put theta here. Sine is opposite over hypotenuse. I'm going 3, 5. Now, that's a famous one. It's a 3, 5. It's obviously 4 right there. Hope you know that. That's 4. So you need all 3 sides. So if sine is 3/5, cosecant reciprocal. Come back to the triangle. Cosine is adjacent over hypotenuse, which would be 4/5 because adjacent's right beside it. Secant's reciprocal of that. Tangent's opposite over adjacent, which is 3/4, and cotangent's reciprocal of tangent, so it's 4/3. Hope that's good. Number 11. You need to fix this for me. I messed up on the practice test. That should be 3/2. So again, I need to draw my triangle. I'll come up here to the top. Draw my triangle just like I did a second ago. Theta down here. This is sine again. Oh, sorry about that. Sine is going to be 2/3. It's reciprocal of cosecant, so I can do that. Sine is opposite over hypotenuse. So I need to find the third side. This isn't a famous one. That's not a 2, 3. I don't know what that is. So I'm going to go 2 squared plus b squared equals c squared, which is 4 plus b squared, which is 9. Move the 4 over. That's 5. Take the square root. You get the square root of 5. So the third side, square root of 5. So cosine, adjacent over hypotenuse. Secant is the reciprocal of that, so I'm going to flip that. You cannot leave the square root on the bottom. Remember, take the radical to the top, take the number out on the bottom. It always works with square roots. Tangent, opposite over adjacent, do the same thing. Square root to the top, take the number on the bottom. Cotangent, I'm just going to flip that one because they're reciprocals. Square root of 5/2. All right, I don't have many words for 12 and 13, guys. These are ones you're supposed to know. I gave you that chart, showed you the triangles all week. You got to learn those things. Cosine 60 is a half, sine 45 is square root 2/2. You just got to know those. 14, find f of g and then tell the domain. F of g, you're going to plug g into f, function g. So function f has a big square root. I'm going to put function g, which is x squared minus 5, where the x was. If I do that, the 5's cancel. Leaves me x squared in there, which is just x. Now, it also said do the domain. Don't forget the domain. And the way you do domain on these, you do domain of the second function, the g. So I'm looking over here. There's g. I'm like, okay, there's no fraction or square root there or radical, which means the domain of that is all real numbers. Then look at the final answer. There's no fraction. There's no radical there either. It's also all real numbers. So what's the domain? All real numbers, because that's what they have in common. The domain of those is what they have in common. All right, number 15, determine algebraically whether the function's even, odd, or neither. First of all, look at the exponents. The exponents are 100% odd, which means it cannot be even. There's no way that's even. So to try odd, you plug in a negative x and a negative y. So I'm going to put a negative y that side. I'm going to put a negative x this side. Now, we'll say this while I'm putting this in here. If their exponents were even and you wanted to test if it was even, you would only plug in a negative x. Your y would stay the same. Okay, now if I plug that in, a negative to an odd power stays negative. So it's going to change the sign on that 4 to negative. Same thing here. Negative to an odd power, it's going to stay negative, so it's going to change that sign. Then I'm looking at this. I'm looking at that and I'm comparing it to what I started with, and I'm asking myself 2 questions. One is it exactly the same function as I began with? And it's not. And the second question is it the exact opposite? And it almost is. The only thing that keeps it from being that way is the negative 2 down here is the same as the negative 2 down there, up there, which means it's a neither. It's not odd or even. It can't be even, again, because of the exponents. All right, last set here, last number. Says find g of negative 2. To find that, I got to figure out where negative 2 goes. Well, negative 2 is less than 1. So I'm going to plug it in right there. Negative 2 plus 4 is positive 2. I got to plug in 1 next. 1 is equal to 1. That says x is less than or equal to 1. So I'm going to plug the 1 in the same place. 1 plus 4 is 5. Then I got to find g of 5. 5 is bigger than 1. So I'm going to plug it into that x right there. 8 minus 5 is 3. And there are your 3 answers for 16. Just make sure you get all 3 of those. All right. Hope that helps. Hope you make 100 tomorrow. Got confidence that you will. See you then.